While discussing contents from chapter 11, we studied the quantities like resistance. The other quantity we discussed is specific resistance. So there is difference between these two. Resistance we define for given conductor. Means if I have two conductors A and B, let the conductors in the form of metallic wires. Then we define resistance for conductor A and we define resistance for conductor B separately. So resistance is defined for particular specimen conductor under observation. But specific resistance is defined for the given material. We define specific resistance of metal copper. We define specific resistance for material aluminium, etc. So this is related with that particular material of which the conductor is made of, and thus for given material it is constant. It is irrespective or does not depend on the dimensions. If you take conductor of suppose A and B made up of same material, that is copper and more copper, then specific resistance of copper for both these conductors will be same. It does not depend on dimensions of the given conductor, but it depends on material. If you select the same conductor A dash and B dash having same dimensions as that of A and B, but made up of different material than copper, that is aluminium, then even their dimensions are equal, resistance of these two pieces will differ from each other. Specific resistance for copper as well as aluminium are different. So this is the difference between resistance and specific resistance. Resistance is related with given conductor. If conductor changes, if you change the piece of conductor, accordingly its resistance changes. But unless you change the material of the conductor, for all conductors made up of same material, specific resistance does not change. It is independent of dimensions of the conductor. Remember these points well. Specific resistance depends on the nature of the material we are using to prepare conductor. Not only it depends on material, but it depends on temperature also. For example, if I have the piece of copper having unit length and unit area of cross section, then resistance of such piece is called specific resistance of copper. I will select number of pieces of copper having same dimensions, unit length and unit area of cross section. This is piece A dash, this is piece B dash, this is piece C dash. Their dimensions are same. Their material is also same. You have to keep each of these piece as different temperature. We'll keep piece A dash, suppose at temperature T1. We'll maintain piece B dash at temperature T2. We'll maintain the same piece C dash, suppose as temperature T3. Then it is observed the value of resistance RA dash, RB dash and RC dash are different. Even though their material is same, their dimensions are same, still when maintained at different temperatures, the resistance values of these pieces change. It is observed resistance of piece C dash, which is maintained at high temperature, is greater than the resistance of piece B dash, moderate temperature. It is still greater than resistance of RA dash, where T1 is less than T2 is less than T3. So specific resistance, in other words, is called resistivity, is the function of temperature. For metallic conductors, when temperature of the piece increases, its resistivity also increases. We get linear relation between specific resistance and temperature for given metallic conductor. So today we will discuss temperature dependence of conductor, that is specific resistance. So practically it is proved when after performing experiment, when you deal with such material or you take single piece of copper having unit length, unit area of cross section, go on increasing its temperature. As temperature increases, the resistance of given piece also increases. We have selected piece of unit length and unit area of cross section. For such piece, resistance will be its specific resistance. So it is observed experimentally. Specific resistance of metallic conductor increases with increase in temperature. Graphically, we can show this with drawing graph of resistivity of given material with its temperature. So as temperature increases, resistivity increases and you get linear graph which passes through origin. So this is graphical presentation. Analytically, the relation between resistivity and temperature is expressed in terms of temperature coefficient of resistance. I am dealing with point 11.10 on page number 214. So today we are discussing the point 10.11.10, page number 214. So resistivity changes means what? Resistance of given that particular specimen having unit length, unit area of cross section also changes. So when resistivity gets affected, resistance of the material also changes of that particular piece also indirectly. In general, when you generalize the statement, we can write the same statement in terms of resistance of the conductor also. Basically, the equation is rho at any temperature T is equal to rho naught into bracket 1 plus alpha into T minus T naught. Again I repeat, rho at any temperature T is equal to rho naught in bracket 1 plus alpha, this is the entire term, into T minus T naught, where T naught and rho naught, the values of absolute temperature and specific resistance of given conducting material at 0 degree Kelvin. So if you know value of resistivity at 0 degree Kelvin, then you can find resistivity of given material at any temperature T by knowing the value of alpha. Alpha is called temperature coefficient of resistance. This is defined in terms of rho also. If you rho naught taken in, rho naught plus rho naught alpha T minus T naught, rho minus rho naught upon T minus T naught will be there into rho naught. We can define this alpha like this also. कैसे डिफाइन कर, हाउ टू डिफाइन इट, रो नॉट ने मल्टीप्लाई किया तो रो नॉट हो गया, तो ये बाजू लेस लाया तो रो माइनस रो नॉट आ जाएगा. When you multiply it by for second term, the second term will become rho naught alpha T minus T naught. You retain alpha over here and rho naught T minus T naught you take to denominator. So this will be the definition of temperature coefficient of resistance. When temperature difference means at 0 degree Kelvin you know value of resistivity of copper. Then at any other temperature, suppose 100 degree Kelvin, you can find resistivity of the copper at temperature 100 degree. So rho T will be there calculated by knowing this value, and this is temperature coefficient. If temperature coefficient is large, then T minus T naught should be less, temperature difference should be less. So if temperature difference is small, rho will be large. So this is the expression to find resistivity of given material at any temperature T, knowing its resistivity at absolute zero temperature, absolute 0 degree Kelvin. So this is the expression. Indirectly using the same expression, we can find the relation for resistance also, and that will be, instead of symbol rho, we will use the symbol R. So since resistance is nothing, specific resistance is nothing but resistivity, that is resistance only, the same you can write in terms of R. But this is only for metallic conductors. We are dealing the electric current passing through metallic conductor. So this resistivity increases if temperature of that metallic conductor increases. When temperature is kept constant, the resistivity is a constant function for that given temperature. So this is the last point to be discussed about specific resistance. So by knowing specific resistance of a given material, you can prepare resistance of preferred value. Suppose I want to have resistance of 10 ohm in the circuit. Then what I will do, you select a wire of any material, suppose copper. I have one copper wire. Suppose that wire has area of cross section, let be 1 यूनिट स्क्वायर एरिया है उसका, ऐसा हम लोग एज्यूम करेंगे. सो इफ आई वांट टू प्रिपेयर वन रेजिस्टेंस ऑफ 10 ओम यूजिंग दिस वायर, ऐसा हम लोगों को कैलकुलेट करना है. सो व्हाट इज रिलेशन बिटवीन आर एंड रो अपॉन ए? We have selected a wire of unit area of cross section, that is 1. I have to select length so that we will get the resistance of 10 ohm. You know its resistivity. So R upon resistivity will be required length. So by knowing resistivity, you calculate value of A. So 10 ohm divided by resistivity gives you the length required of such wire to prepare a resistance of 10 ohm. Such type of resistances prepared with the use of these wires are called wire wound resistances. So wire wound resistances you can prepare of any preferred value, desired value, knowing specific resistance or resistivity of given material of which the wire is made of. Suppose the length area is 2. 1 minute. Area is 2. Then this 1 will become 2. Then you have to select length by taking the relation 2R upon rho. So you know you have to prepare resistance of 10 ohm. So you multiply 2 with 10 and then divide it by resistivity, so that you will get, we have made the area double. So length required to prepare the resistance of same value using this piece will be different. So this is the technique when wire wound resistors of desired value are fabricated. But this wire wound resistance when fabricated, when prepared, has large size and hence very hectic. If the wire is broken in between, then that will prepare loose connection in the circuit. And nowadays, hence, carbon resistors are useful. So we will proceed further by with type of resistances. So using this technique of specific resistance, we consider first type wire wound resistances. That can be prepared, that can be prepared easily. So you select the given material, you select the thickness of the given material wire, you select the length required to form desired value of resistance. But if the wire is punctured in between, you cannot know, you never know whether it is punctured, it is broken in between, and even though it is made in circuit, useful in circuit, the circuit always show error. So better way to avoid using wire wound resistors. One of the known wire wound resistance which is adjustable is rheostat. So I have to switch over, I have switched over on point 18, 11.8.1. 11.8.1 on page 212. On page 212. So observe the diagram which is 11.8. In that diagram, they have shown the construction of rheostat, and this rheostat is a type of wire wound resistor. A wire of given material is taken, it is wound on ceramic insulating cylinder, and two ends are at two different positions. So terminal B and terminal A. In between A and B, wire is wound, and terminal C is taken, which is adjustable. So when that is connected in the circuit, variable resistance, you can adjust the length of wire between A and B. The entire length never comes in the circuit. The length of wire in the circuit is either AC or BC. So by changing the length, you can adjust the value of resistance. So rheostat is one of the examples of wire wound resistors. The other type I already told you, carbon resistor. They are very small in size, they are handy, they are nearly weightless, and thus nowadays these carbon resistors are replacing wire bound resistors. Being smaller in size, their resistance values, or they can be prepared, they can be manufactured of any value ranging from 0 ohm to few mega ohm. They cover this range of resistance values. But even though they are very tiny, they are very small in size, and their resistance value is not printed over their bodies. Instead, you get a set of colored rings marked on the carbon resistor at one end, at any one end. We generally get a set of 4 rings. You have to trace the rings from the A side. This is first, this is second, third, fourth, and etc. Generally over the resistance, this is a ceramic body. On the ceramic body, you will get 2 outputs, 2 leads to connect them in outer circuit, and a set of colored rings is printed. By decoding this color set of colored rings, you will find its resistance value. This colored ring system is standardized by Electronic Industries Association and is used worldwide. So now we have switched over to point number 11.8, page number 211. Page number 211, carbon resistors. So these carbon resistors are very small in size, very cheap, and fabricated on the large extent, large amount, and hence we use them in different functions. So now we'll start with color coding, that is decoding. So color rings printed have different colors. We have to remember one sentence. B.B. Roy of Great Britain has very good wife. Start numbering these sentence from extreme left starting with 0. So first be 0, second be 1, 2, 3, 4, 5, 6, 7, 8 and 9. Using this standard color code, you have to decode the value of carbon resistor and to get its resistance value. First B is for black, second B is for brown, third B is for blue, first G is for green, and second last G is for gray. Remember these points well. So using this standard color code, we can find resistance value. On page number 212, they have given one sample example. Open page number 212. They have mentioned one example. The color code of resistance is yellow, violet, orange and gold. Fourth ring is generally either silver or gold, or there might not be the fourth ring. How to decode this color code? First two colors gives you first two significant digits in the value. Means you have to write down their digit. So yellow is number 4. The second significant digit, violet, for violet, it is number 7. V for violet, 7. So you will get 2-digit number 47. The third place gives you its decimal multiplier. Here is orange, that is number 3. So you multiply this number with 10 raised to 3. Decimal multiplier means the factor, the power over the digit 10. And the last thing, gold or silver, gives you its tolerance. For gold, the tolerance is plus minus 5%. So first two color rings, first two significant digits, third color ring, decimal multiplier into 10 of that particular power, and fourth ring, either gold or silver in fourth place, gives you the tolerance. What is meant by tolerance? Tolerance means the carbon resistors are not fabricated for all values. Means you never get carbon resistor having value 1 ohm, 2 ohm, 3 ohm, 4 ohm. For each ohmic value, that carbon resistor is not fabricated. They are fabricated for only given particular values, and they then gives you tolerance. Tolerance means for 5%. Means the same resistance, that is 47,000 ohm, is its value. Plus minus 5% means 5 plus 5% of 47,000. So what is 5%? 5 upon 100. So this 2 will get cancelled. Left will be 5. 5 nines are 45 and left will be 2, 5 fours are. So you will get 94. So this resistance is useful for the range of resistance value 47,000 plus 94 ohm to 47,000 minus 94 ohm. Means if you want resistance of value 47090 or 46021, then for that values also you prefer this resistance. This tolerance gives you the range for that particular resistance. For that particular range, in between this particular range, you can find or you can use it in external circuit. So this is color coding of carbon resistors. In your exercise, open the exercise. It is on page number 220. 220 open karo sab log. In question number 4, sub question number 9 IX. I have asked you to open page number 220. Question number 4, sub question number 9. Find the value of resistance for which the following color codes are. Number 1. For example, I will solve one more. Again, you see question number 10. They have given the resistance value. By using that resistance value, you have to code in it in color coding. For example, 330. What is 330? First digit 3, that is third one. 3 belongs to orange color. So first thing will have orange color. The second will also have orange because both are 3 3. The third is 10. 33 into 10. 10 means 10 raised to 1. So third should be 10 raised to 1. 1 belongs to brown, not for black. It is brown. So third color ring should be brown. And they have given common tolerance, that is 10%. So that 10% belongs to gold, silver. So last string should be of silver color. So on the carbon resistor, if you have color code rings in the sequence orange, orange, brown, silver, its value will be 330 plus minus 10%. So it can be used from 10%. 10% यानी कि कितने हो गए 330 के 10 upon 100. So 1 by 10. So that will be 33. So 330 plus 33. So 363 up to 330 minus 33. So will be 792. So this is particular range. So this resistance is used wherever you want the resistance in the circuit between 297 up to 363. So you can either decode it or you can code it using standard color code. B.B. Roy of Great Britain has very good wife. First black, brown, blue, green, grey and V for violet. So we have completed color coding and decoding to find the values of carbon resistors. So today we will stop. I will close the meeting for all. Tomorrow we will continue with the next point of the same chapter. Thanking you all. I am closing the meet. Thank you.